This says representing relationships between independent and dependent variables. Okay. It says the county fair charges $1 per ride and an additional $3 to get into the fair. We're going to write an equation that we can use for that situation. So, raise your hand if you've ever been to the fair, the Shawan County Fair. Okay, so I went for the first time this year. Okay. And do they have rides at the fair?
Yes.
Okay. Yeah. I went to the fair and I didn't ride any rides. Does that mean I didn't have to pay any money?
No, you've got to pay entry fee.
I had to pay to get in, okay? So don't forget that you've got to pay that entry fee in order to get in. So it says that the county fair charges $1 per ride, okay? And then an additional $3 because you have to get into the fair. There's that entrance fee. We're going to write an equation that represents the total cost of us attending the fair. Those people that raise their hands, raise your hand if you rode rides when you went. So you paid more than I did when I went to the fair because you had to pay for the ride. Now, independent variable, I. What is it that you're choosing? What is it that you get to choose? Raise your hand if you can tell me. Which of the two things that we've highlighted would be the independent variable? The number of rides. So number of rides. And we know that independent is which part of the coordinate plane, X or Y? Where's independent going to go? Oh, well, it is, but think about if you look back at these notes that we did, which part of the coordinate plane is going to be independent? Is it the x-axis or y-axis? Which one? Look at it. It's going to be x. So this is x. Now the dependent variable, which has to be the y, is going to be what? What is it that we're going to be finding out that's going to answer the question when we solve the equation? The cost, total cost. Okay, so to get that total cost, we're going to have to put some things together. So when you go, you got to pay what first to get in?
Entry fee.
Okay, so write an equation that shows the relationship between the independent and dependent. So how much is each ride? $1. So if I rode 5 rides, how many dollars would that be?
$5.
Okay, so it's a 1-to-1 ratio. 1 ride, $1. 10 rides, $10. So the number of rides is going to equal the number of dollars. What am I going to do with the number of rides, which I'm going to put what? What variable is that going to represent? X. Okay, now I don't just pay for that. What else do I have to pay for? To get in, how much was that? So what am I going to put with my rides and the $3 to get a total? What do I have to put with the rides and the entry fee to get a total? What operation? Addition. So I'm adding 3 to that. So the number of rides, I've got to pay for those. It's $1 for each one. And I had to pay to get in, and that's going to equal what? Y. The total cost. Okay. So X, remember, is going to be what? The cost of the number of rides, right? And then what are we doing after that? My rule is going to be what? What am I going to do after I get the rides? I'm going to add 3. Okay? And then what is Y going to equal? The result. So let's go through. If I have X, what's the least number of rides I could ride? 0. Okay. What am I going to do with the 0? Okay. What am I going to get for an answer? So my ordered pair is going to be, what is X? 0. What is Y? That is my ordered pair. Okay, let's say that I rode 3 rides. If I rode 3 rides, DeMarcus, how am I going to figure out my total cost? What am I going to do with the 3? Add what? And what is that going to equal? All right, so I'm going to make my ordered pair. What's my ordered pair going to be for this? My ordered pair is going to be what? DeMarcus? It's going to be a 3-6. All right. Now, let's say that I ride 5 rides. I rode 5 rides. What am I going to do with the 5, Georgia? What do I do with the 5? Add 3. What is y going to equal? 8. So my ordered pair is going to be 5, 8. All right, let's say I rode 12 rides. What am I going to do with the 12, Lacey? Okay. And what am I going to get for y? And so then my ordered pair is going to be 12, 15. Now, we're going to use that information here, our ordered pair, and we're going to graph below. Okay? So, I have my first ordered pair is 0, 3. I start at 0. Do I go to the right or left? I stay there. And then where's 3? 1, 2, 3. I'm going to put a point right there. That's our first ordered pair. The second ordered pair is going to be what? 3, 6. So if I start at 0, where do I go?
To the right 3 times.
1, 2, 3. And then?
Up 6.
Up 6. 1, 2, 3, 4, 5, 6. Right here. Okay? Next one. How am I going to graph the next ordered pair? I'm going to start at 0. Where do I go? To the right. How many? 5. And then? Oh, so there's 5, 6, 7, 8. Right here. And the last one. Where do I go? All the way to 12. So that's 10, 11, 12. And then at 12, I'm going to go up to 15. And that is going to be, let's see, 12 up. That's 10, 11, 12, 13, 14. Oh, it's at the very top, isn't it? All right, so do those points line up? Okay, they do. If I were to take an index card, are they all on a line? Okay, here's the thing. So I'm going to draw the line. That means there's a relationship. Okay, there's a relationship between them, but it's not proportional. It's not proportional because it's not going through this special part of the graph. If I go to the fair and I don't ride any rides, is my entry fee 0? No. I have to pay what? $3. So it's not proportional. I cannot use multiplication to go from X to Y. If it's proportional, you can. I can't change 12 to 15. I could do 3 to 6's times 2, but does that work from 5 to 8? So it has to be the same for each one. Okay? So at the bottom, we're going to put not proportional. Not proportional. Does not include the origin. Now, it does have a relationship. It's not multiplication, it's what? Addition. And so that is our relationship, is adding. It's not proportional. Proportional has to be multiplication. Any question?